Okay, hello. When I say we, I'm going to go through this exam paper that I set you for homework so you can mark it. I've done this on the little whiteboard, so obviously it will look slightly different to how you see it, but yeah, this is just how it's going to go. Hang on, move this. Okay, so we start off with a multiple choice. So this is the front page. This is page number 1. You should spend a maximum of 20 minutes on this section. 4 springs. A, B, C, and D are made of 4 different materials. Use the equation force equals extension times spring constant if excellent. If we arrange, so that is F equals X times K. We want to know about the spring constant, so we go F over X equals K. Which force over extension gives you the greatest one? It's this one, the greatest gradient, because F over X is the gradient. So the answer here is A. Oop. There we go. What is the current at point Q? The current at point Q, if we've got, check this works, we've got 2 amps here, we have 2 amps here. The rules for series is the same everywhere. So we have 2 amps here. The answer is B. Let's go down here to the next question. Which of these is the gravitational field strength of Earth? That's just something you have to know. It's 10. Close enough to 10. So C is the correct answer. Which of the following is a scalar quantity? Displacement is a vector, force is a vector, velocity is a vector. So it has to be distance. So the answer is B. Oops. A solenoid can be used to produce a magnetic field. Which of the following increases the magnetic field strength? Decreasing the current? No. Decreasing the number of terms? No. Increasing the current? Yes. So C is the correct answer. Zoom out, bring it over there. Which of the following transfers the most energy? Energy is equal to power times time. So the first one is 1,000 times 1. The second one is 2,000 times 2. The third one is 3,000 times 1. And this one is 500 times 4. So that equals 1,000. That equals 4,000. That is 3,000. That is 2,000. So this one is the biggest. So B is the correct answer. Which of the following is not part of the atomic model? Almost all of the atom's mass is contained in the nucleus. That is true. An atom's nucleus contains positive neutrons. That's false. It's the protons that are positive. So the answer is B. Which row, A, B, C, or D, shows the largest change in thermal energy? The largest change in thermal energy, we have the equation is, for those of you who are interested, the equation is mass times specific heat capacity times delta T equals energy. So it's basically this times this times this all across. These are all the same, so that's not really a factor. This one has a larger mass, but this one here has the largest temperature change. So for question 8, the correct answer is A. And let's zoom in the last couple to get them both on the same page at the same time. And what is the acceleration between point A and B on the graph? This is a velocity time graph, so the acceleration is all about the gradient. That is the worst triangle in the world, so I'm sorry. So change in y, which is 4 over change in x, which is 24, 20, gives us 0.2. There we go, that's cheap. Read the answer, so I couldn't do the maths in my head. B is the correct answer. 4 compasses are placed near a wire at points A, B, C, and D. Each wire has a current flowing through it. The distance for each compass from the wire is shown. Which compass has the greatest magnetic field strength? So magnetic field strength is all about the current and how far you are. A larger current will have a larger magnetic field. Closer will have a larger. So which one has the largest current and is closest? That's 2 and 1. Not very much. It's 2 and 2. It's not very much. This is so it's not a sum, is it? This one is 4 amps and at 1 centimeter. C. Highest current, closest to the wire. That one is the win. Okay, let's move on to the next question. A student has 2 lamps. She wishes to connect them both, so both lamps have a maximum brightness. Draw a complete circuit diagram. There we go. Let's give it a cell, a battery, and check, does it want any symbols for... Okay, that's fine. We don't need an ammeter and voltmeter. So 1 lamp and 2 lamps. So basically they are in, so it's not parallel. Parallel. Okay, so if you got the symbol for a battery or a cell and the symbol for a lamp, 1 mark. If you made a complete circuit, so you have 1 loop at least, where the cell and the thingy are connected, that's 2 marks. And if you put them in 2 lamps in parallel, that is your 3rd mark. Check. Student then investigates the unknown component to record the value for current through the component and the potential difference across the resistance. Here we have, there we go. Let's move out. Plot a graph. Oh no, I didn't realise we had to plot a graph. I'm regretting this already. Let's find a way. Let's move this over here so I can see them together. Okay. Alright, so here we have, so the first one has been done for me, so also I'm not very good with this pad. So 2 volts is 1, 3 volts is 1.5, 4 volts is 2, and 2.5 is up here. And do a line of best fit. Oh man, this is going to be tricky with the computer. Oh, that was awful. Your line of best fit should hopefully go through all. No, I'm still ashamed. This should go through those points. A nice straight line should hopefully go through the origin. What do these show? These show that current and PD are directly proportional. Now, 1 mark. You could say, in other words, as current increases, potential difference increases. As PD increases, current increases. There are other ways of saying it, so it doesn't really matter as long as you get the same message. Calculate the resistance. Resistance is PD divided by current. So ideally, you do the gradient, but my line is awful, so I can't do that. And then do the inverse. So let's just pick a point. Here we go. 1 and 0.5. So 1 divided by 0.5 equals 2 ohms. You have to write the sum for the first mark, and the answer is the second mark. Here we go. Next one. So, a student wishes to calculate the average speed of a toy car travelling down a ramp. He releases the car without pushing it from start point A. Here it is. The car's going to go zoom. Oh, that was a good line. I was kind of impressed with that. Write down the instruments he could measure. He takes measurements of distance and time. Write down the instruments. The distance, he could use a meter ruler or tape measure. And for time, you could use a timer or a stopwatch. How can you calculate the average speed? The average speed is just distance divided by time. Easy peasy. The student has an idea about the experiment. He thinks the greater the angle of the ramp, the greater the average speed. Look at his results. They've done the same distance, 1.2 each time. The time has changed. Calculate the average for 20 degrees. So distance over time is 1.2 divided by 2 is 0.6, and then meters per second. Oh no, it wants 0.60 because it says 2 sig fig. 0.60 meters per second. I keep forgetting to change this. Do these support the student's idea? So the student's idea was, zoom out, sorry. The idea was the greater the angle of ramp, the greater the average speed. Now look, at the lowest angle, you have the lowest speed. Oh no, you don't. At the lowest angle, you have medium speed. At the highest angle, you have the highest speed. And there's more than one correct answer for this scenario. Do these support? So you can either say yes or you can say no. If you say yes, because steepest angle equals fastest. But you could also say no, because shallowest angle did not equal the slowest. So there's more than one correct answer, but the most important thing is yes and an explanation, no your explanation. If you just say yes, you don't get any marks. If you just say no, you don't get any marks. You must explain why. Another student thinks the experiment could be improved. They could do it themselves then. It's just one in problem. There was no repeats. So the improvement, 2 repeats. For example, they also only did few angles. You could do more angles. What else could they do? Calculate average as well. So come up with an idea and say why it's better. I don't know how you get 3. So there we go. Okay, here we go. Here is a proper 6-mark question to test yourself. It may look quite scary, but there's not too much to worry about. The graph below shows the change in temperature of a material as it cools. Describe and explain what the graph tells us. Okay, so things we need to talk about at this point here. So describe at 42 degrees C, the graph is horizontal. The graph is horizontal. This is a change of state. Hopefully you remember that from the specific heat capacity questions. When the temperature doesn't change, it means the object is going through a change of state. Also, things we notice about the graph. This bit here is steeper than this bit. So starts with steep gradient / temperature change. which then slows down. And we notice here it's pretty gentle change, gentle slope after gentle slope after change of state. So we have it in one state of matter, so we have two different states of matter shown, two different states of matter. So maybe solid and liquid, or gas and liquid. And we have a change of state, bigger change. It changes more dramatically. Is that maybe not the same? It changes more dramatically here than it does here. Yeah, that's it really. A student has a wooden cube. Find out how they measure the density of the wooden cube. Okay, so the first thing you need to do is you need the equation to work out density. Density, then density is equal to mass over volume. Okay. Sorry, put that on. You measure the mass with digital balance or scales, and you measure the volume by measuring the measure depth, width, height, and then multiply that times that, and that equals the volume. So you need this equation, 1 mark. Talk about how you get the mass, that mark, and how you get the volume for your 3rd mark. When a material changes, its density changes. When a material changes state, its density changes. Talk about particles. Okay, so you could do diagrams. Oh, we're good with this little thing, this little pad. So that will be a liquid. That's the worst diagram I've ever done. But let's see if I can do a better one for a solid. Bit better than the gas. These two should be the other way around. How many marks do you get for a diagram? I get 3 marks for each, 1 mark for each diagram. That's sick. Gas, solid, liquid. And basically, we have more space between atoms in gas compared to solid and liquid. 4 marks. It does say solids are denser than liquids and liquids are denser than gases. That's not actually the same for water, so I don't know that. I think if you just basically talk about the different states, how their particles are arranged, we get 1 mark each, and then talk about as the particles or atoms or molecules or whatever move further apart, there's more space, so their density goes down. Okay. During a rocket launch, a rocket accelerates upwards with a force greater than the downwards force. Name the forces. Upward force is up thrust, or just thrust would work, and the downward force is weight, not gravity. It says allow gravity. Sometimes it doesn't allow gravity. You have gravity then, but you're only cheating yourself. At launch, the upwards force is 10,000. The downwards is 8,000. What is the size of the force? So 10,000 minus 8,000 equals 2,000 newtons. And this up a bit. A rocket has a mass of 800 kilograms. Calculated acceleration. So force over mass equals acceleration. So 2,000 over 800 equals 2.5 meters per second squared. Nice. Relatively easy. A student uses a small motor to lift a toy car through a vertical distance of 1 meter. The car has a weight of 0.05 newtons. Calculate the work done. Work is force times distance. Okay, probably get 1 mark for writing that equation. The force, 0.05, and the distance is 1. Wow, tricky. So the answer is 0.05 joules. Calculate the power of the motor if it takes the car 0.5 seconds to travel the it's 5.0 seconds. Well, power is energy over time. So the energy is 0.05 divided by 5, 0.01, and the power is in watts. So you get 1 mark for this bit. Now in the equation, 1 mark for writing the numbers in, another mark for the answer, and the 4th mark for saying what. The motor uses 2 cells in series. Each cell has a potential difference of 1.5 amps. Write down the potential difference of the cells. 1.5 in series with another one is just 1.5 plus 1.5. One cell, another cell. So the answer is 3 volts. The motor has a resistance of 6 ohms. Calculate the current in the circuit when the motor is in use. Use the equation. PD is current over resistance. So we want to know the current. So we do PD over resistance gives us the current. So the PD is 3 and that is 6. So yeah, where we go? 0.5 amperes. The student wishes to increase the time taken to lift the toy car vertically through 1 meter. Suggest the change he could make to the experiment. Well, if you've got 2 cells, if you remove a cell, that will make the whole thing go slower. You can increase the mass of the car by adding weights. Or masses. You could also add a resistor to the circuit, but that's just weird. Add a resistor to the circuit. Okay, that's the whole test. Easy peasy. I'll stick the mark scheme with this somewhere too, so you can check, particularly for the longer answers, because there'll be some wording that I'm sure you'll get correct as well. Hope that helps. Okay, bye.